Hello students, in the previous class we have completed operations research, that is branches of operations research like linear programming problem, game theory and replacement theory, inventory theory and transportation theory. Today we will learn about theoretical distributions. Theoretical distributions are based on probability distributions. Theoretical distributions are also known as probability distributions. Under probability distributions, we have discrete probability distributions and continuous probability distributions. In the previous class, that is in PUC first year, you studied about the concept of probability, and this is the continuation part of theoretical concept of probability. In our day-to-day life, we come across many random variables such as marks scored by candidates in PU examination, IQ of children, number of female children in a family having 3 children, and we can find out height of students, weight of students, and number of accidents occurring in a city per day. Okay, for a quick analysis of distributions of such random variables, we consider their equivalent theoretical distributions. Here, theoretical stands for expected values or estimated values or calculated values. Theoretical values or theoretical frequencies are nothing but expected values or estimated values. Fine. Theoretical distributions are originated according to certain theoretical assumptions and restrictions. Probability distribution of a discrete random variable is known as discrete probability distribution, and probability distribution of a continuous random variable is known as continuous probability distributions. As I have already told you that there are two types of probability distributions, discrete and continuous. If the distribution is based on a discrete random variable, then it is known as discrete probability distributions, and if the probability distribution of a continuous random variable is known as continuous probability distributions. And here some of the discrete probability distributions are listed. First one, Bernoulli distribution, binomial distribution, Poisson distribution, and hypergeometric distribution. These are some of the discrete probability distributions. Next, continuous probability distributions. We have normal distribution, chi-square distribution, and student state distribution as continuous probability distribution. So first we will learn about Bernoulli distribution. If x is a discrete random variable with the probability mass function, here the expression for Bernoulli distribution, the mathematical expression for these discrete probability distributions are known as probability mass function, PMF. If x is a random variable, if x is a discrete random variable with the probability mass function, P of x equals to P raised to x into q raised to 1 minus x, where x takes the value 0 and 1 and p lies between 0 to 1 and q equals to 1 minus p, where p is the probability of success and q is the probability of failure, and the value of probability always lies between 0 to 1, and here x takes the values 0, 1, that is 0 stands for failure and 1 stands for success. Then x is a Bernoulli variate. The distribution is called Bernoulli distribution, and the examples for Bernoulli distribution are number of heads obtained in the toss of a coin, number of male children when a baby is born, when a stone is aimed at mango tree, it may hit or it may not hit, and some of the features of Bernoulli distribution are, some of the features or properties of Bernoulli distribution are, Bernoulli distribution has one constant, namely p, which is the parameter of Bernoulli distribution, and range for Bernoulli distribution is 0 and 1, that is x takes the value 0 and 1, and PMF, probability mass function for Bernoulli distribution, is P of x equals to P raised to x, Q raised to 1 minus x, where x takes the value 0, 1, P lies between 0 to 1 and Q equals to 1 minus P. And next is mean of the Bernoulli distribution is P, variance is PQ, and SD is root of PQ. And fifth property is mean greater than variance, that is symbolically you can write P greater than PQ. So Bernoulli distribution with parameter P. The parameter for Bernoulli distribution is P. Parameter as well as mean for Bernoulli distribution is P. Bernoulli distribution with parameter P can be written as follows. X is a random variable and P of X is the probability of that random variable. So X takes a value 0 and 1, where X takes a value 0 and 1, that is where 0 stands for probability of failure and 1 stands for probability of success, and the probability of failure, that is P of 0, is denoted by Q and P of 1 is denoted by P, and the total probability is always 1. So this is about Bernoulli distribution. Next one is binomial distribution. If X is a discrete random variable with a probability mass function, P of X equals to NCX, P raised to X, Q raised to N minus X, where X takes value 0, 1, 2, 3 and so on up to N. Here binomial distribution is nothing but N times of Bernoulli distribution. If you repeat the experiment up to N number of times, then it becomes a binomial distribution. For example, in case of Bernoulli distribution, when a coin is tossed, we may get head or we may get tail. When a coin is tossed, we may get head or we may get tail. But in case of binomial distribution, the condition is like toss the coin until the head is obtained, or toss the coin until the tail is obtained. That is, here the same experiment is repeated N number of times. Okay, here X takes the value 0, 1, 2, 3 and so on up to N. And the probability of X, P of probability mass function for binomial distribution is given by P of X equals to NCX, P raised to X, Q raised to N minus X, where N, because the experiment is repeated N number of times, that's what here it is NCX, and P raised to X, P is probability of success and Q is probability of failure, and X is a random variable which takes the values from 0, 1, 2, 3 so on up to N. As usual, where P lies between 0 to 1, Q equals to 1 minus P, then X is a binomial variate and the distribution of X is called binomial distribution. And some of the examples for binomial distribution are number of heads obtained in 4 tosses of a coin. Next, number of male children in a family of 2 children. Number of bombs hitting a target among 3 bombs which are aimed at a bridge. And the number of seeds germinating among 10 seeds which were sown. And some of the features are as follows. N and P are the parameters of binomial distribution and is denoted by B of N comma P. And the range for binomial distribution is X takes a value 0, 1, 2, 3, 4 so on up to N. PMF is given by P of X equals to NCX, P raised to X, Q raised to N minus X. X takes the value 0, 1, 2, 3 so on up to N. P lies between 0 to 1, Q equals to 1 minus P. And fourth one is mean equals to NP, variance equals to NPQ, and SD equals to root of NPQ. And fifth one is mean greater than variance, that is NP greater than NPQ. Sixth one, mean and mode are equal when NP is an integer. Mean and mode are equal when NP is an integer. Next one is if P equals to Q equals to half, that is 50%. When you toss a coin,